Okay, today I will just go through the answers for the atomic structure quiz. Let's look at question 1. The graph for the second IE of a period 3 element is given below. And if you look at element B, it has a very high second IE. So which means it has a very stable X plus structure. Because X plus 2, X2 plus E, this is second IE. So which means X plus must have a noble gas configuration for it to be very stable, which means this element here must be in group 1. So if that's group 1, this must be group 2 and this will be group 13. So in this case, you need to know the electronic configuration for element D. So element D is in group 13, alright, and it's also in period 3, and there are only 3 electrons in outermost shell. Hence it will be 1s2, 2s2, 2p6, 3s1, 3s2, 3p1. So there are 3 electrons in outermost shell and it's also in period 3. Alright, so this group 13. Okay, let's look at the next question. Okay, the next question, they say this is the IE graph versus the number of electrons removed. Say deduce the group in which period in the periodic table to which X is likely to belong. So what we are looking for is the big jump. Alright, so from after removing the first electron, it takes a lot more effort to remove the second electron. So what it means is this second electron is from an inner quantum shell. Alright, so what it means is this electron here, right, let me just say this. So this electron here must be in the outermost shell. So which means there's only one electron in the outermost shell. So let's see how we answer this. This element must be in group 1. So there's a largest increase in energy to remove the second outermost electron. So this second electron must be from an inner principal quantum shell, right? So this element is potassium. How do you know that? Because it's in period 4. Okay, so let's look at the third question. Okay, ground state, please memorize it. Okay, the term ground state is used to describe atoms whose electrons occupy their lowest possible energy levels. So it's how you fill up normally, right? So let's look at let's look at this element EU, europium. Okay, it has actually 63 electrons. So let's follow this Orbital principle to fill up the electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 3p6. So after 3p6 is 4s2, then 3d10, right? So there are already 30 electrons. So after 4s2, it will be 3d10, then 4p6. After 4p6 is 5s2. 5s2 will be 4d10. After that be 5p6, followed by 6s2, followed by 4f7, right? So for this case, this is europium. So if they ask you to draw europium with a charge of 2+, you're supposed to remove the 6s electrons, the 2 of them. So now this part becomes the valence electrons, because on the outermost shell is the 5th shell now. So you're supposed to draw 5s2, 5p6. So this is what it should look like. Okay, let's look at the next one. Okay, right, so you're going to calculate the angle of deflection of chromium 2+, given the angle of T plus having an angle of 5 degrees. So how you do this question, you can find the angle of deflection of 2 plus divided by the angle of 1t plus. Okay, so we know that angle of deflection is proportional to the charge over the mass. So for this case, is 2 plus 2 over 54 over plus 1. The charge is plus 1 and the mass is 3. So the angle of deflection, this is unknown, but the angle of deflection of t is actually 5 degrees. So imply when you solve it, x degrees is equals to plus 0.56 degrees. Okay, if you do for cobalt, angle of deflection for cobalt 3 plus over the angle of deflection of t plus. Okay, the charge is plus 3, the mass is 60, the charge is plus 1, the mass is 3. So I don't know this angle, but I know this is 5 degrees. Work it out, x will be equals to plus 0.75 degrees. Okay, the last one for O2 minus. So angle of deflection for O2 minus. Okay, we compare against T plus. So it's going to be minus 2 over 16 divided by the charge, which is plus 1, divided by 3. This is x degrees over 5 degrees, and you work it out, x will be equals to minus 1.88 degrees. So what it means when they say minus means it's actually deflected in the opposite direction, because these two are positively charged and this one is actually negatively charged. So it'll be deflected in the opposite direction, right? Okay, let's look at the next part. Okay, you need to determine the overall charge of particle Q. So they say mass of particle Q is 22 times that of this. So and then its angle is that deflection is plus 0.45, right? So I'm going to say angle of deflection of Q. This is the charge is n plus. Let me see, the mass number should be 66. So when I compare against T plus, right, we know that this will be plus n over 66 divided by plus 1 divided by 3. So this angle is 0.45 degrees and this angle is 5 degrees. So if you solve it, n will be equals to 2, right? So the overall charge is actually plus 2. Okay, let's look at the last part. So the particle Q contains 30 protons, but Q actually has a charge of plus 2. So Q having a Q2 plus, I would say, would have, if it has 30 protons, it must have 30 minus 2 equals to 28 electrons, right? So that's the number of electrons, and hence write its configuration. So Q, we have to write the configuration for Q2 plus, right, we need to start by writing the configuration for Q first. So with 30 electrons, okay, Q has 30 electrons, 1s2, 2s2, 2p6, 3s2, 3p6. So far we have 18 electrons. So it's 20 electrons and then 30 electrons. So with 2 plus, we must remember to take away from 4s first. So 2 plus, Q2 plus would be this, 3s2, 3p6, 3d10, alright? Okay. Alright, suggest a reason why IE of halogen molecules decreases down the group. So generally, as the molecule becomes bigger, the valence electrons are further from the nucleus. So when the valence electrons are further away from the nucleus, they'll be less strongly attracted to the nucleus. Hence, it's going to be easier to remove an electron. So the IE will actually decrease.